I'm going to explain the elimination method. Here we already have y equals 10. We know the value of y in this problem is 10. Here we have y equals x2 plus 1. We're going to change of sides 1 to here. But because we already know that y is equals 10, we're going to substitute, make it 9 equals x2. This is square, so we make a square root. The answer of x will be 3 and y will be 10. Thank you.
What we have here, it's a graph, and we have to find out if it's domain, its range, and if it's a function or not. First, what is a domain? A domain is how far it goes on the x-axis to both sides. So, as we can see, it goes on and on, and on both sides. So it has no end. So it's negative infinite, and it goes on until infinite. Positive infinite. And the range is the same thing on the y-axis, and it goes only on until 1 and negative 1. It's the farthest it goes. So we put first the negative, and it's negative 1 and positive 1. Now we have to find out if it's a function or not. How do you know if it's a function? You know if it's a function if you can draw any line at any place, and it will only hit one spot. So here, if I draw a line anywhere, it will only hit one spot. So it's yes, it's a function. Thank you.
Solve and simplify. I have these two problems. I'm going to solve one by one. Okay? In parentheses 3i the square. In my class, we know I as 1i equals the square root of negative 1. 2i's equals negative 1. I to a cube equals negative 1, a square root negative 1. And I to a fourth power equals 1. So knowing that rule, we can know that I to a second power will be negative 1. So 9 to a second power, 9 times negative 1, negative 9. This is your answer. Following the same rule, we know parentheses is the first thing you have to do. So I to a second power equals negative 1, 2 to a second power, 4, negative 4. Negative 4 times negative 5i will be positive 25. That is the answer. Thank you. ¿Qué haces?
Yeah. So right here we have to solve the following linear equation, which is 1 over x plus 4 over x minus 3 equals 7 over x. So the first step we have to do is we have to find the least common denominator, which would be x times x minus 3. And we have to multiply this to make it match the least common denominator. So it would be 1 times x minus 3. You only multiply it by x minus 3 because you already have x right here. So then you skip to the next one, and it would be plus 4, and you will only multiply it by x since you already have x minus 3. And it would equal 7 times x minus 3 since you have x right here. Once you have the least common denominator, you can cross it out since they all have the same one. And the only thing you will have left is this. And so let's multiply. So first it's 1 times x, which is x, minus negative 3 times 1, it would be also negative 3, plus 4 times x, which is 4x, equals 7 times x minus 3, which is 7x. 7 times negative 3 is negative 21. And now we have to unite them. Simplify, I mean. So x plus 4x is 5x, and negative 3 remains the same, equals 7x minus 21. Now we're gonna put the x's with the x's and the normal numbers with the normal numbers. So we're gonna bring negative 21 to this side, but when you change the side you have to change the value. So instead of being negative it would be positive, so it would be negative 3 plus 21, and we do the same with the x's. We bring this x to the other side and it would be brought as negative 5x. So it's 7x minus 5x. Negative 3 plus 21 is 18, and 7x minus 5x is 2x. Now we have to divide, get x by itself, so we are going to divide here by 2. And what we do on this side we must do on the other side. So it's 18 divided by 2, which is 9. And there you have it. X equals 9. And that's it. Thank you.
I'm gonna solve problem 47 of the final lab. So our problem is parentheses 13x4 plus 7y2 parentheses times 13x4 minus 7y2 parentheses. So the formula to solve this is a special problem. So the formula is parentheses a plus b parentheses times parentheses a minus b parentheses equals to a2 minus b2. So we're gonna apply 13x4 to the second power minus 7y2 to the second power. This is a and this is b. So you can solve this. Here is a and b. A and B. So we're going to apply 13 times 13 is 169, and x4 to the second power is x8, minus 7 times 7 is 49, and y2 to the second power is y4. So this is our final answer of this special product. Okay, I'm gonna solve problem 58 of the final lab. The equation is 36 m4 n3 plus 24 n3 n3 minus 60 m n3. So we're gonna factor these numbers. So to factor this equation we need to find the greatest common factor. The greatest common factor is 12 and 2 and 3. Because 12 is the greatest common factor to multiply this number, and this number. So we're gonna put here the greatest common factor, that is 12, m2, and 3. So here we're gonna try to find the number that this multiplying this number that we don't know will get 36 m4 and 3. So the number is 3 m2. Okay, now we're gonna find the number that this number multiplied by the number we don't know. We're gonna get 24 m3 and 3. So the number is plus 2m. Okay, now we're gonna find the number that this number multiplied by the number that we don't know. We're gonna get this one. So is -5. And this is our final answer.